We have been building the metro map activity from the YByte Python curriculum. In fact, we are almost close to the end. You can see that we have two lines on the display. All the stations have been added to these drop down menus. The only thing that we need to update now is to, update the calculation of the fare. Basically, right now, if my two stations are on the scratch line, it all works fine. So for example, costume to broadcast, it's 20 rupees. Costumes to, let's say, my blocks, it's going to be say 80 rupees because four stations in between. But the moment I have any of the stations on the Python line, right now nothing happens. We will see in this video how do we enhance this project to incorporate this line. In fact, it's also very logical. Let's analyze this carefully in a step-by-step manner and implement it in this, in this video. Now, really, when we have two lines, there are two possibilities that come up. For example, the first situation is that the starting and ending situation stations are on the same line. Now, in fact, this was guaranteed when we had only one line because obviously both the stations are on the same line. This question is guaranteed. This question doesn't arise. It's always like this. But now there's a possibility that, maybe I start on the scratch line and I go to scratch line. I go and start on the Python line. I go to the Python line. But there is also a second possibility, which is that the start and the ending stations are on different lines, which means, for example, I start in scratch line, I go to Python line, I go to, I start Python line, I go to scratch line. So what we really need to do is to sort of extend our logic to both of these conditions. So let's just take a look at what we will do and then we'll implement that in code. So it becomes easy. In fact, the steps here are very, very logical. Remember, we get the start and the stop as the two stations that have been chosen from those drop down menus. We first figure out whether the start and stop, which lines are they on. So if, for example, if start in the scratch line, then I demarcate a line called start line as, the scratch line. Otherwise, I make it the Python line, and likewise for the stop line. Now, once we do this, we know that there's a distinct start line and a stop line, and then we can go further. Now, just a technical point. In fact, what we are doing here is creating a shallow copy of the station SL and station PL, but that should serve our purpose. If you are interested to discuss this more, do leave a comment. I'll be very happy to take this forward. Once we do this, then remember there are two conditions. One is that start line is the same as a stop line. So again, I just do exactly what I was doing earlier, because, on the same line. If they're on the different line, then I just figure out, okay, I need to go to the interchange. From the interchange, I need to go to the next line and go to the stop station, which means that I do this in two steps. I first compute the number of stations between the start and the interchange on the start line. Next, I compute the number of stations between the interchange and the stopping index and add that to whatever I had got. Now, makes sense, if you think through this carefully. Again, we are using a is statement here, not equality. That is okay in this case, but again, that's related to the fact that we are doing a shallow copy over here. Like I said, I'm happy to discuss if you are interested. So let's get to our code and start building this. Remember, our all of this has to happen inside this inside this function called calculate fare. Previously, I was also always picking up start line as being equal to, let's say, the scratch line. Here now I just ask a question. Well, if start is, let's say, STNSL, which means this list station SL contains, let's say, the starting station, then start line is equal to this the start scratch line. Else I say start line is, say, equal to STN underscore PL. Now I can just copy this whole code over. So I take this and I replicate this code here. However, I must do the same here for the stop. So I figure out first, what is my, so I say stop line is scratch line, and here I just go and fix again stop line is, let's say, Python line. So very logical. If the starting station is in scratch line, well, that's the start line. If the stopping station is scratch line, that's the stop line, and vice versa. Having done this, I just have to accommodate both the conditions. So I say, okay, look, if start line is, let's say, stop line, which means they are basically pointing to the same line. In that case, I am going to do exactly what I was doing earlier. No change here. Maybe I can put a small comment here, same line. And on the other hand, let's say else, I am going to have to, let's say, say different lines. I'm going to copy this code because pretty much the same logic will hold. So I'm going to do this 2 times. Remember, first I figure out on my start line to get from the starting station to, let's say, y byte. Now remember, because we're doing a we are doing an app, so it doesn't matter. I can do y byte minus the index of start, because basically I'm figuring out how many stations to get to the interchange, which is the y byte station here. Next step, I take the number of stops from the previous line, and I add that to the number of stations that is required to go from y byte to, let's say, to say y byte. Now, in fact, I could, like I said, I could have changed either of these because I'm doing an absolute value. So I could have changed here. I could have also changed on this, but makes sense. On one of these, I must have stop. And one of these I must have I byte, but obviously I must do this on the stop line because that is where my station is. Now, think about this carefully. It's kind of very clear if you look at the graph, and it becomes quite logical. And this is really all we need. We can now, in fact, see this working. So, for example, let's say first, let's pick up from the same line. Let's say sprite land to say, for example, cloning. I say calculate fare, tells me 100 rupees because 1, 2, 3, 4, 5. On the other hand, from sprite land, if I were to go to Turtle Park, which is, let's say, from one corner of the city to another corner of the city, it tells me 160 rupees. That's because 4 stations to the interchange, switch over 4 stations once again. Say I want to go from Turtle Park to, let's say, having roamed around Turtle Park, I want to go to, say, escape character, the other side of the Python line. I click this, calculate fare. It's again 120 rupees because 1, 2, 3, 4, 5, 6. This time I stay on the same line. But let's say from Turtle Park, I want to go to, let's say, cloning. So I click on this. It's 100 rupees because 4 stations on the starting line, in this case, the Python line, switch over to the next line, and that's the one stop over here. So I get, like, 100 rupees fare because 5 stations. Again, like I said, my fare scheme can be made more elaborate, but you get the idea. Very, very, very logical, and very sensible. I hope this is clear and this is enjoyable. Take care, enjoy this process, go through this systematically because quite interesting, really. If you like this way of learning programming by building activities, do look at our website because we have many, many such activities. Take care. Thank you so much. Bye bye.